study the operating system. First we'll go to the concept. How the operating system evaluated. So what is an operating system? It's basically a program that acts as an intermediating between user of a compiler and the computer hardware. Now, what is the purpose of operating system? To provide an environment in which a user can execute programs. So what is the goal of this operating system? It makes the computer system convenient to use and use the computer hardware efficiently. The operating system provides the means of proper use of these resources in operation of the computer system. I'll go to the computer system structure. The computer system can be divided into four components. First is hardware. It consists of CPU, memory, input-output devices. The application program, which defines the ways in which these resources are used to solve computing problem of the user. And the user which tries to solve different problems. For example, the users are people, machine, and the computer. And the operating system, which controls and coordinates the use of hardware among various application programs. Basically, it has following components: the user compiler, assembler, text editor, database system, a number of users which are connected to the compiler or assembler or text editor or database system, and the operating system is connecting to the system of application programs and the hardware. What are the basic features of the operating system? It allocates the memory for the program and loads the program to the memory. The instructions provided in the program are executed by the CPU. Keep the track of the instruction that was last executed, which enables it to resume a program if it had to be taken out of the CPU before it completed execution. If the program needs to access the hardware, it makes a call to the operating system rather than attempt to do itself. After the program has completed execution, the operating system clears up the memory and makes them available for the next program. Now in this connection, we will study OS operating system definition. So it works as a resource allocator. That is, the operating system acts as a manager of the resources and allocates them to specific program and users as necessary for the task. And it is a program controller. That means it controls the execution of the user programs and operation of input-output devices. The computers were physically enormously large. The input device were card reader and tape driver. The common output devices were line printer, tape printer, or card puncher. The user of such system did not interact directly with the computer system. The user prepared a job which consisted of the program, the data, and some control information about the nature of job and submitted to the computer operator. Now these are the serial processing. What are the drawbacks of the serial processing? In scheduling, machine time reservation is needed for program installation. The reserve time were multiple of a block of time. The problem is program finishes before time, so wastage of time will be there, and program need more time. And the execution stops before completion of the task. The setup time, a considerable amount of time was spent just in setting up the program to run. Earlier, machines were very expensive and it was important to maximize the machine utilization. So, rid of the problem, we are having solution batch system. So, for simple batch system, we are having operating system with user program area. And the memory layout for a simple batch system is the simple batch system as central idea. It uses a piece of software known as operating system. Here, user no longer has direct access to the machine. The computer operator batches the jobs together sequentially and places the entire batch on an input device for use of the operating system. The operating system maintains a program counter to switch the jobs. The advantages of crosspoint of this, despite of memory and execution time overhead, the batch processing system improves utilization of the computer. And the main drawback is since the input-output devices are much slower compared to the processor is often idle. The solution is multi-programming or multitasking system environment. Idea of multi-programming based system is if there is enough memory to hold the operating system and multiple user programs, the process idle time can be utilized by the program waiting to execute, not waiting for input output. This process is known as multi-programming or multitasking. It is the central theme of the modern operating system. The multi-programmed batch system. What is the operating system features needed for multi-programming? Where we are having job scheduling, memory management, CPU scheduling, input-output routine supplied by the system, and allocation of devices. In job scheduling, we are having several jobs are needed to be brought into memory, and there is no enough room for all of them. And the system must choose among them, making this it's called job scheduling. When the operating system selects a job from job pool, it leads the job into memory for execution. Several programs in memory at the same time requires having some from the management. The CPU scheduling, here the several jobs are ready to run at the same time. The system must choose among them, making the decision the CPU scheduling. Now the input-output routine supplied by the system and allocation of the devices. In time-sharing systems, the CPU is multiplexed among several jobs that are kept in memory and on disk. The CPU is allocated to a job only if the job is in memory. A job swapped in and out of memory to the disk. I'll go to desktop systems, where the personal computers and pro devices uses convenience and responsiveness are the features of desktop systems. First, we'll go to personal computers, where the computer system dedicated to a single user, input-output devices, which are having keyboards, mouse, display screens, smart printers. Now, user convenience and responsiveness is the feature of this system. Here we can adapt technology developed for larger operating system. Often individuals have sole use of compiler and do not need advanced CPU utilization or protection features. We run several different types of operating systems, the Windows, Mac OS, Unix, Linux, etc. We'll go to parallel systems. Here, the multiprocessor system with more than one CPU is in close communication with each other. Now, tightly coupled system processors share memory and a clock. Their communication usually takes place through the shared memory. And the advantages of parallel system: it increased throughput, it's economical, and also it increased reliability, edge, graceful degradation, and fail subsystems. I'll go to distributed systems. Distribute the computation among several physical processors. It's a loosely coupled system where each processor has its own local memory. Processors communicate with one another through various communications lines such as high-speed buses or telephone lines. Advantages of these distributed systems: resource sharing, computational speed of that is load sharing, and communications. It requires networking infrastructure, local area networks that is LAN or wide area networks that is WAN, maybe either client server or peer-to-peer systems. A clustered system. Clustering allows two or more systems to share storage. Asymmetric clustering. One server runs the application while other serves standby. Asymmetric clustering, where all hosts are running the applications. And good real-time systems, often used as a control device in a dedicated application, such as controlling scientific experiments, medical imaging systems, industrial control systems, and some research systems. It's well-defined fixed time constraints. Handheld systems, which is personal digital assistants and cellular telephones. Basically, the issues are limited memory, slow processors, and small display screens. This is how the migration operating system concept and features has been developed, starting from 1950 to 2000.
Gimana? Saya gimana?
Start with the